Hello students, welcome to Grade 9 Euclid's Geometry Introduction. Ancient Egyptians were perhaps the first people to study geometry. They were mainly using it for finding areas of rectilinear figures, triangles, rectangles, etc., or for finding volumes of granaries and for constructing canals or building pyramids. Geometry developed by them consisted of statements of results. There was no general rule of the procedure. The Greek mathematicians were, however, interested in establishing the truth of the statements they discovered using deductive reasoning. The Greek mathematician Thales gave the first proof of the statement that a circle is bisected into two equal parts by its diameter. The Greek mathematician Pythagoras demonstrated the famous Pythagoras theorem. By 300 BC, a large body of geometric knowledge was in existence. That means lots of geometrical results were available and were known to the people. At this time, a teacher of mathematics at Alexandria in Egypt collected all known work and arranged his famous book, The Elements. Euclid gave many definitions, axioms, and postulates. Now, what are axioms and postulates? These are also assumptions or results. Axioms are related to mathematics and postulates are related to geometry. Let us consider few of the definitions given by Euclid. A point is that which has no part. A line is a breadthless length. The ends of a line are points. A straight line is a line which lies evenly with the points on itself. A surface is that which has length and breadth. This statement contains two undefined terms, that is length and breadth. The edges of a surface are lines. A plane surface is a surface which lies evenly with the straight lines on itself. Postulates means assumptions used in geometry. Axioms means assumptions used in the study of mathematics. Euclid gave few axioms. Some of them were things which are equal to the same thing are equal to one another. If equals are added to equals, the wholes are equal. If equals are subtracted from equal, the remainders are equal. Things which are coinciding with each other are equal to one another. We can take one example here. I have this sheet as A4 size sheet. Again, one more sheet I am taking. I notice that it is coinciding with it. So I can say that these two equals, these two things which are coinciding with each other, they are equal. A whole is a greater than part. It doesn't require any explanation. Things which are double of the same thing are equal to one another. Things which are halves of the same thing are equal to one another. Euclid's postulates. First, a straight line may be drawn from any one point to another point. A terminated line can be produced indefinitely. Here this dark one is a terminated line. It can be extended on any of the sides indefinitely. Third, a circle can be drawn with any center and any radius. That means you can draw a circle of any size. All right angles are equal to one another. Here, if PQR is 90 degree and LMN is 90 degree, then PQR and LMN are equal. Fifth postulate, which is the most important one, if the straight line falling on two straight lines makes the interior angles on the same side of it taken together less than two right angles, then the two straight lines, if produced indefinitely, will be meeting. Right? That means if I am having PQ and RS right? And this MN is a line which is passing through them. And sum of the angle 1 and angle 2 is less than 180, then these two lines are going to meet towards P and R. That means if you extend them here, they are definitely going to meet at some point. There are several equivalent versions of this postulate. One of them is Playfair Axiom, which was given by Scottish mathematician John Playfair. That is, the statement goes like this: for every line L and for every point P not lying on L, there exists a unique line M passing through P and parallel to L. I hope it's clear. There is a line L and there is a point P here which is not lying on L. From P there will be infinitely many lines passing through it, but there will be only one line M which will be parallel to L, not all, right? This result can also be stated as that two distinct lines which are intersecting cannot be parallel to the same line. Two lines, right? They are intersecting each other. Maybe we take this M and we take this red line. All right, out of these, only one of them will be parallel to L. Both of them cannot be parallel to L. Sample questions. Define the following. Parallel lines. Two or more lines are said to be parallel if and only if they lie in the same plane but do not intersect. Distance between them remains equal throughout their length. Perpendicular lines. Two lines are said to be perpendicular if they intersect to form right angles. If they intersect to form right angles. Next, line segment. It is a part of line consisting of two endpoints, A and B. Radius of a circle. It is the line segment from center of the circle to any point on the circle. Square. It is a quadrilateral with all sides equal and all angles equal to 90 degree. Or we can define it's a rectangle with adjacent sides equal. Question 2. If a point C lies between 2 points A and B such that AC is equal to BC, then prove that AC is equal to half of AB. Explain by drawing the figure. So this figure you need to draw. Given C lies on AB such that AC is equal to BC. C is the midpoint. Add AC on both sides. So if I add AC on both sides, I will have AC plus AC is equal to BC plus AC. Equals are added to equals. Hence the wholes will be equal. That means twice of AC will be equal to AB, which means AC is equal to half of AB. Question 3. If in a figure AC is equal to BD, then prove that AB is equal to CD. AC is equal to BD, we have to prove AB is equal to CD. So we proceed like this. Given AC is equal to BD, but what is AC? AC is AB plus BC. And what is BD? BD is BC plus CD. And these two are equal. So I can write AB plus BC is equal to AC plus CD. Now subtract BC from both sides, which means AB plus BC minus BC is equal to BC plus CD minus BC. BC and BC cancel, BC and BC cancel. I am left with AB is equal to CD. Hence proved. So here we finish this chapter. Thank you.